Hi. Okay, we are live. Good morning. Today we are August 12th, which happens to be my birthday, but that is not relevant. What is relevant is that I did not stream yesterday, and I should be angry with myself. What happened was I stayed very night for work on Sunday because we did like an internal company hackathon. And so on Monday I just woke up at 10. So that completely ruined my sleep schedule. Yesterday I was trying to sleep at 10. So I went to bed at 10, but I couldn't fall asleep. So that was also very frustrating. But we need to get back on track to waking up at 6 so I can do longer live streams. And I'm just going to keep repeating myself. I know I'm going to sound like a broken record, but I guess the process of saying these things out loud is probably going to help me. It's better than not saying it, I guess, right? Like, obviously the best thing is if you could actually do it, but habits are really hard. But as long as you think about this and you remind yourself, eventually I think you're going to get it. I was in a good flow, but it's, life gets in the way. But if you let life get in the way, it's probably because you have other things going on. But anyways, today, instead of reading a paper, I was thinking a lot about, because I'm going to go back to school soon, and I am going to want to do research, and I'm trying to think about what is the research that is important, and specifically, I'm very interested in working in robot learning, right? And so, specifically manipulation, and there are sort of like these two things that really pique my interest, which are role models and reinforcement learning. And so each has a particular goal, right? Like reinforcement learning is really interesting because this is sort of how teaching robots to learn on their own, right? Like the way they're able to learn on their own is through this process of discovering how valuable different states are, right? So you have your Q and your Q functions. I mean, if you do value-based RL. If you just do policy optimization, I think I'm not familiar with the policy-based optimization, even though we spent a little bit of time going through DRPO, PPO. Where did I do vanilla policy gradient? No. Yeah, I remember doing the derivation, but I don't remember. Like, where did I? Oh, maybe I did it on paper. Yeah, I definitely have a video somewhere where I derived it. Always good to have it written here, but it's in my live streams. Okay, maybe I should just quote myself in one of my live streams.
Hello.
25%. Wait, oh, for sure. Isn't, oh, wow, I'm gonna ask ChatGPT that. Isn't the not all information learned is useful to. Do I do it somewhere here? Gong. More RL review.
Hello.
Yeah, I think I did it. In this live stream. I did derive the policy gradient method somewhere, but I don't really remember. I mean, I kind of remember there's like a cost function, and then you take the log, and then you take the gradient. But the specific steps, I don't fully remember. But back to this topic. Why is reinforcement learning really interesting? Because it is a way to teach our robots to learn on their own. How do they learn on their own? By learning this concept of a value function or some other way to. I don't know if policy gradient methods don't directly learn the value function, but they learn how to work towards some reward. Like the reward in this case is just a sparse reward, whether you complete or do not complete the episode, right? So if you don't complete the episode, you get -1 reward. But if you complete the episode, you get this positive reward signal of 1, right? And that is sort of sufficient for the robot to work on its own. And where value-based RL is really interesting is that it enables you to, well, policy gradient methods are not very sample efficient, whereas value-based methods are. Policy-based methods are generally on policy. On policy means that you generally don't learn from, you only learn with one policy as opposed to 2 different policies. Off policy works because of when you update your queue, you always take the max, and so that ensures that the queue also always is learning towards the optimal policy. And generally it's very, very, the way reinforcement learning has been solved recently for manipulation has been doing, well, the paper that we were looking at was like action chunking with transform, sorry, not action, is queue chunking, right? This idea of doing queue learning with action chunking. So reinforcement generally is just some form of queue learning in the manipulation world. We don't see like, do we see policy gradient methods for manipulation? I have not. And where world models, so generally reinforcement learning has been model free, which means that you don't need a model of your system. You just query your system like a black box. It will return you a new state and a new state, and you're gonna use that, right? You sort of don't know the dynamics of what happens when you have a state in action, what happens in the next state, right? And that makes it quite sample inefficient. Like if you actually had the dynamics, you could just directly solve it via dynamic programming. But world models, what that do, okay. So reinforcement learning, you can just think of it as QSA, right? So this gives you a value function. And world models, what they'll do, okay, maybe the way to do this is like state in action and gives you a Q score. And what role models, what they do is they will take a state in action and give you a new action, right? Learning the dynamics of the world. And so why do I think role models are important in our path? Okay, so I'm thinking about how to achieve AGI robotics. What's missing? What's missing is the ability for robots to self-improve over time robustly, right? So the issue right now that I'm seeing, based on my personal experience too, is just like, it's really, really hard to get your robots to self-improve without just getting worse, right? So if you like train it on its own demonstrations, successful demonstrations as a way to get more data, it just doesn't work quite well, right? And we can run these experiments and you can see it. And so why is that? It's like, imagine, I guess, like if you go golfing and you look at an amateur who can hit the ball, right? But it doesn't hit the ball quite well. And you learn like his form of hitting the ball. Like he's gonna get worse at playing golf, right? Even though like, oh, I can successfully hit the ball. So you need to be able to quantify how good your swing and strike is. And that's where this Q function is, right? The how does the Q learn? Well, this is just based on the reward, right? So in golf, that would be like how centered the ball is, or like if you just care about hitting the ball far away, then maybe. But like if it takes longer, then like the time it takes for you to get that reward is the thing that is optimized for, right? But the queue just optimized for the queue, right? It just learns. Sorry, the queue is just optimizing for the return, right? Yeah, or like it represents. Or it represents the expected return of the optimal policy if you're talking about Q star here. Now, if you only have a queue, right, then what you can just do is you take this queue and you sort of use that to steer your policy, right? And eventually you have a stronger policy, you have a stronger queue, and jointly this will help you become like get a much more robust policy. And this is what the paper has shown us, right? But there's still like a fundamental limitation, I feel like, of the policy. So I feel like ideally, like if we could bake this world model understands the dynamics of the world. And I was particularly interested in these papers, the Dreamer paper. Right, if you can somehow do these predictions. So first of all, this policy is quite naive, right? The policy, what it takes, what it does, is simply take a state and outputs, or you can do, all right, all it does, the policy, is take a state and predict the next action. There were methods where they took a series of states from like the past and then directly output an action, right? And that's called proprio history, but it hasn't really worked. But yeah, this is sort of the general form. So you take your policy and you get this action. But notice that it sort of doesn't have any reasoning about any understanding of what potential state it might end up in. Because remember, when we're training the policy, all we're doing is just conditioning it on state, right? Okay, here's the state, and then here's where, here's what you need to do at the state, right? And this is just like trained on imitation learning. Even when you do this reinforcement learning, right? After you do like state and action, like you do this Q steering, and then maybe you do like implicit policy extraction, which means you will just sample from the policy multiple times, and you end up in you get a better action, right? That the Q will score, and you train your policy on that, so it's training on its own data, and it gets better, right? Even with that, I feel like that will not be sufficient, just because the policy itself is restricted on the current state, right? Like for us, we have an understanding of the history. So there's, I guess, a few components. Like perhaps you don't need, no need for proprio history, but you probably do, right? Like perhaps what we need is this Q to actually be a role model, right? So instead of S prime, perhaps what you need is, perhaps we need a Q world model. I don't know if anyone tried this, right? Because you can imagine the Q's loss is just like learning the expected return, right? And the world model, what it's doing is a lot of like, world models generally today are like generative models, where they'll predict the next pixel, and the loss will be conditioned on this next pixel, right? Like, ideally what we want is some sort of joint model, where we take SA, and this jointly spits out S prime and Q, right? So, and then what you can do is sort of like use this policy condition on A, S prime, right? Huh. It's conditioned on S. How do you want your policy to use this, right? Like, really, like there's a few ways to do this. It's like one first method, first way. It's 3-stage. You have your queue. Sorry, you have a world model. So one is one policy sampling. Then two, you get these actions. You query the world model. The world model will give you new states given to get S prime given SA. And then you get query the queue function conditioned on all three. Like, perhaps you don't even need like we also have the concept of a value function, right? Sorry, like of a V function. And V of S, that's similar to the Q, but you don't have this action scoring, right? You just have V. Like, isn't QSA S prime just V of S prime? Oh, really? I should be recording this. We need appropriate history somewhere, right? Because you need some way for the robot to remember its decisions. Like, it does seem like world models are not really needed right now. Yeah, I think there's policy. The problem with multi-stage learning is that there are much more points of failures. And especially if you work in a latent space. Like, I guess here we can write down multi-stage efficient and there's past token prediction that sort of shows that it's important for the policy to attend to past actions. Huh. Yeah, this is
related than the expert. motivated by these observations, like different actions to select the best.
These guys are pretty good. Good job, Marcel. Ah, il parle français. Okay, you gotta work on your resume though. Like who? How did bro? This is not the resume you can read. Okay. Yeah, in this case, they sample multiple actions, and then their selector is not based on some queue function. It's actually just based on which action is the most consistent, which is very interesting. But the premise of this paper was that you want to have your policy predict past actions as well as future ones to improve temporal Yeah, I think actually what you can do like, yeah, I've been thinking about the world model should just bake. Maybe how do we bake a world model into our policy? Right? So we take some state and it gets compressed to some latent represent. This is Dreamer, by the way. This is S in some latent representation, and you predict in your latent representation, and then you get your using these two information you can get an action. Actually, like you jointly predict what will your next state be if you like. I feel like this might not be necessary. And so as you train, you don't only get better at predicting because there's another, like if you think about all the permutations, there's really like two models like this, right? One of them would predict, okay, I'm in the state and the next state. How do we get AGI, right? Yeah, I do think so. How good are I feel like these are the things that are missing right now beyond just behavior cloning, right? Like you just scale up your data, like perhaps there's reasoning or search. Like I think right now it's too stupid. Like behavior cloning works because it's learning on just good actions, right? Okay, just learn to copy him. Like you don't know why it's good, but you know you're good. You can just do it, right? And sort of the robustness. This is her robustness. Here. Yeah, in this case, it's like robustness is more optimizing for the worst case. Alright, what happens when you end up crashing? Learning the dynamics of the world. Like, what's wrong with this? Second way. Take the world model into it. That's A. We use flow matching for our action, right? Some sort of diffusion, which means that there's sort of like two disjoint ways. And so your state is actually some sort of flow matching, right? Two disjoint like modalities. Like, I feel like having the Q separate of the pi could actually be like, it's actually somewhat bad. Like, is there a value in attributing a score? Doesn't this just collapse E of S prime? counterfactual reasoning. I guess the issue is cube SA V like maybe the model hallucinates that we can end up in this like ideally really good state, right? But we can't actually, like, perhaps following error. S prime computer like. Yeah, I need to go soon. Like reachable. In which case you end up with like catastrophic failure, right? Instead of like, how do we I've been thinking about how we solve agent. That's true. I forgot about goal conditioning. Guys, some people started thinking about this. Alright, I need to get to work. But it's been nice thinking about these things, and perhaps you want to continue thinking about these.